Hi all, this is Dr. K. Raghuram Mohan Reddy, Associate Professor, Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. The course name is Unconventional Machining Process. Topic is Definitions and Terminology of Plasma Machining. Okay, right. So here the course name is Unconventional Machining Process. The topic is Plasma Arc Machining. Okay, right. So at the end of this session, student will be able to understand the various definitions and terminology of the plasma arc machine. Right. Now let us discuss the various questions associated to this plasma arc machine. The number one question is, what is the principle of plasma arc machining? What are the two stages in which the process of material removal is affected? Okay, right. Plasma arc machining, in simple, it is PAM, plasma arc machining. Okay, right. Material is removed by directing a high velocity jet of temperature around 11,000 degrees centigrade to 28,000 degrees centigrade. Imagine how maximum it is. Okay, so when we go in sunlight, if the temperature exceeds just 45 degrees centigrade, then we cannot bear. Okay, so imagine, in order to melt the various metals, we have to have some huge temperature that it is possible by the plasma arc machine. So in this, the high velocity jet of temperature around 11,000 degrees centigrade to 28,000 degrees centigrade, okay, which ionize the gas on the workpiece. Okay, so this high temperature plasma jet melts and material of the workpiece. Okay, melts the material of the workpiece. Plasma formation and melting of workpiece are two stages. Okay, plasma formation and melting of workpiece are the two stages in which the process of materials removed is affected. Okay, so here one is formation of plasma and the other one is melting of workpiece. Okay, right. Second one, what is the main industrial application of plasma cutting systems? Okay, right. Let us have two important applications. It is used for cutting alloy steels, stainless steel, cast iron, copper, nickel, titanium, aluminum, and alloy of copper and nickel. Okay. Second application is that it is used for profile cutting. Okay. So applications of plasma cutting systems can deploy for various materials such as alloy steels, stainless steel, cast iron, copper, nickel, titanium. Okay, titanium, which is having a high hardness. Okay, and its high strength to weight ratio have the good properties towards the some biomedical applications and some other important industrial applications. So we have to machine titanium, though it has high hardness. So for that we have to use plasma arc machining or plasma cutting system. Okay. So however, aluminum and copper, all these are soft materials, but we can use these materials for plasma cutting systems. Okay, and it is used for profile cutting. Okay, so instead of machining irregular components like surface milling and taper turning and plane turning like that, we have some complex profile cuttings. Okay, like gaze. Okay, so at these systems we can use plasma arc machining. Okay, right. What do you understand by fourth state of matter. Okay, third one, fourth state of matter. The dynamical properties of this gas of free electrons and ions are sufficiently different from the normal unionized gas. So it can be considered as fourth state of matter and is given a new name, plasma. Okay, the dynamical properties of this gas of free electrons and ions are sufficiently different from the normal unionized gas. So it can be considered a fourth state of matter and is given a new name, plasma. Okay, right. Right. What are the gases used in plasma arc machining? Okay, so in plasma arc machining, we can deploy the following gases. Okay, the commonly used gases are nitrogen, hydrogen, air, mixture of nitrogen and argon, hydrogen, etc. Okay, so the following gases and the combination of some gases can be deployed for the plasma arc machine. Okay, nitrogen, hydrogen, air, mixture of nitrogen, hydrogen and argon, hydrogen. Okay, right. Define plasma. Okay, define plasma. Plasma is defined as the gas which has been heated to a sufficiently high temperature to become ionized. Okay, plasma is defined as the gas which has been heated to sufficiently high temperature to become ionized. Okay, in order to have the ionization process, we have to maintain high temperature so that it melts and vaporizes. Okay, that is nothing but plasma. Okay, right. What is the purpose of etchants in chemical machining? Okay, right. Purpose of etchants in chemical machining. Etchants are used to remove the metal from the workpiece. Okay, the metal is removed by the chemical conversion of the metal into metallic salt. Okay, so here etchant is a chemical that can be used to remove the material from the workpiece. Okay, the metal is removed by the chemical conversion of the metal into metallic salt. Okay, right. Name the etchants used in chemical machining. Okay, caustic soda. Okay, the first one is caustic soda. Second one, hydrochloride acid, nitric acid, iron chloride. Okay, caustic soda, hydrochloric acid, nitric acid, iron chloride. So these are the various etchants used in chemical machining. Okay, what is the use of muscat in chemical machining? Okay, in chemical machining, the area of the workpiece which are not to be machined are covered with a resistant called a resist or muscat. Okay, in chemical machining, the area of workpiece which are not machined are covered with a resistant called a resistor muscat. See, usually you can see on white paper, if we apply some candle, when you rub on the white paper with a candle, suppose if you pour some ink, that ink cannot occupy that candle rubbed region. Okay, so in similar fashion, here one piece of profile that it can be placed on the workpiece in order to not to machine. Okay, so that is called muscat here. Okay, so the Musken materials may be solid or liquid or semi-liquid, that we'll discuss. What are the advantages of plasma arc welding? Okay, what are the advantages of plasma arc welding? Right, exothermic oxidation takes place. Okay, second one, DC power supply. Okay, so these are the two advantages of plasma arc machining. Okay, right. What are the metals that can't be machined by plasma arc machining? Okay, what are the metals that can't be machined by plasma arc machining? Okay, stainless steel, monil, soprel alloys. Okay, so these are the three materials that can't be machined by plasma arc machining. Okay, right. What is the basic heating phenomena that takes place in plasma arc welding? Okay, the basic heating phenomena that takes place at the workpiece is a combination of anode heating due to direct electron bombardment recombination of molecules on the workpiece. Okay, the basic heating phenomena that takes place at the workpiece is a combination of anode heating due to direct electron bombardment recombination of molecules on the workpiece. Okay, right. 11th one. How the initial ionization is accomplished in plasma arc machining. Okay, a high voltage arc established between electrode and nozzle accomplishes initial ionization. Okay, a high voltage arc established between electrode and nozzle accomplishes initial ionization. Okay, right. Right. Why does gas formed in plasma do in plasma arc machining? Okay, so this gas stabilizes the arc and prevents it from diverging. Okay, so this gas stabilizes the arc and prevents it from diverging. Okay, right. How another source of heating achieved in plasma arc machining? Okay, how another source of heating achieved in plasma arc machining? Right, this is 13th question. It is desirable to achieve a third source of heating by injecting oxygen into work area to take advantage of exothermic oxidation. Okay, right. It is desirable to achieve a third source of heating by injecting oxygen into work area to take advantage of exothermic oxidation. So when we supply oxygen onto the workpiece, what will happen? The exothermic reaction or exothermic oxidation will take place. Okay, right. Write the principles of plasma arc machining. Okay, once the material has been raised to molten point, the high velocity gas stream blows the material away. Okay, once the material has been raised to molten point, the high velocity gas stream blows the material away. Okay, so that is the principle of plasma arc machining. Okay, so what is happening? Raised. Okay, once the material has been raised to molten point, the high velocity gas stream blows the material away. Okay, write the circuitry details in plasma arc machining. Okay, so let us see the circuitry details in plasma arc machining. Positive terminal connected to workpiece and negative terminal connected to electrode or 2. Okay, so here workpiece is positive and this electrode is the negative terminal, that is cathode. Okay, this is anode, this is cathode. Okay, right. Which type of power supply is used in plasma arc machining? DC power supply is used. Okay, so here direct current power supply is used in plasma arc machining. Okay, which part is constricted by plasma? Okay, which part is constricted by plasma? Nozzle duct is constricted by plasma. Okay, here the nozzle setup is the important parameter here, which constricted by the plasma. Okay, right. How does the basic plasma is generated? Okay, how does the basic plasma is generated? The basic plasma is generated by subjecting a stream of gas to the electron bombardment of the electric arc. Okay, the basic plasma is generated by subjecting a stream of gas to the electron bombardment of the electric arc. Okay, how does the basic plasma is generated? Very important one. Okay, the basic plasma is generated by subjecting a stream of gas to the electron bombardment of the electric arc. Okay, what are the metals that can't be machined by plasma arc machine? Okay, usually we cannot machine a few metals by using plasma arc machine. Okay, we cannot machine stainless steel, we cannot machine monem, we cannot machine super alloys. Okay, right. So before we finish, let us rewind the important points of this presentation. Okay, right. See here, it is very important point that the temperature. Okay, in plasma arc machining, the material is removed by directing a high velocity jet of high temperature, that is about 11,000 to 28,000 degrees centigrade ionized gas on the workpiece. Okay, so this this high temperature plasma jet melts the material of the workpiece. Okay, so this is the important point. 11,000 to 28,000 degrees centigrade is developed. Right, and one more important point is that what is the purpose of etchants in chemical welding? Etchants are used to remove the metal from the workpiece. Okay, so etchant is a chemical here. Okay, that it is used to remove the workpiece material. Okay, so the metal is removed by the chemical conversion of the metal into metallic salt. Okay, so here the material is dissolved. Okay, because of the chemical action. Okay, right. Name the etchants used in chemical machining. Okay, caustic soda, hydrochloric acid, nitric acid, iron chloride. So these are the various etchants used in chemical machining. Right. What is the use of muscant in chemical machining? Okay, so muscant is a template that it stops the machining, that it avoids the machining. Okay, so let us say this is the workpiece. Okay, we do not want to machine in this particular area, so where we have to provide a template, there the machining will not be taking place. Okay, in the rest of the area of that surface, the machining will be taken place because of the chemical action. Okay, Suppose if you won't keep anything, the chemical will occupy that area so that the machine will be taking place. Okay. So here the agent or chemical trying to remove the material on the surface where the musket avoids the chemical reaction on the particular area. Okay, in that area we have to provide the musket. Okay, right. Some important points we have discussed in this presentation. So with this, let us conclude. Okay, thank you very much.
Like, share and subscribe. Hit the bell icon for more updates.